Water got in. Where can it go? When moisture enters a wall, its ability to leave may depend on more than one direction. But a wall does not simply dry because someone calls it vapor open. In this lesson, drying potential means the potential for moisture to leave an assembly as water vapor. The moisture moves gradually through materials, not through visible gaps. That is different from air leakage through openings. Air leakage is a separate transport mechanism, moving moist air through gaps rather than diffusing through solid materials. Vapor diffusion is not the same as air leakage, and neither is the same as liquid water entry through a defect. 3 different mechanisms, 3 different problems. Some assemblies may have more outward drying potential. A cyan path moves toward the exterior through a lower resistance outer path, while the interior side stays more resistant. Others may have more inward drying potential. A cyan path moves toward the interior through a lower resistance inner path, while the exterior side stays more resistant. Some assemblies may have potential in both directions, but the pathways may not be equal, and direction and rate depend on conditions. Every layer contributes resistance to vapor diffusion. A conceptual wall has an interior finish, an interior control layer, cavity insulation, sheathing, exterior insulation, and a cladding zone. Changing the order, type, or facing of one layer can change the available drying paths. The same insulation material can behave differently in different wall assemblies. Drying conditions can change. When the exterior is cool and the interior is warmer, vapor pressure pushes one way across the wall. When the exterior is warmer and the interior is cooler, the gradient can reverse, and cyan arrows may change in direction and strength. Drying is not fixed in one direction forever. Temperature, relative humidity, solar heating, rainfall exposure, and indoor conditions can change the vapor pressure conditions across the wall. Drying potential can be part of moisture resilience, but it does not replace control of rainwater, plumbing leaks, ground moisture, or moist air leakage. First, consider a small temporary moisture load, where a potential drying path may help. Second, ongoing water entry, where source control remains essential. Third, air leakage carrying moist air, where air control continuity remains essential. Drying potential does not equal permission for water entry. To evaluate drying potential, start by asking, where could moisture come from? Sources include rain, indoor air, plumbing, and construction moisture. Next, ask what resists vapor diffusion. Every layer matters. Then ask, what are the available drying paths? They may be inward, outward, both, or limited. Finally, ask what happens at transitions. Joints, penetrations, and openings must be checked separately for air and liquid water control. Walls may have inward drying potential, outward drying potential, potential in both directions, or limited drying potential. Actual performance is assembly specific. A wall may have potential to dry inward, outward, or both ways, but the complete assembly and the conditions it experiences determine whether that potential is useful. Next node, the double vapor barrier problem.